Hi, welcome to my channel JaberTime. Today I'm going to go over graphing quadratic functions from standard form, and here's some graphs. They're going to be opening up with the axis of symmetry. The focus is on the axis of symmetry, the Y-intercept. This graph opens down. We're going to see 6 examples. Here's the first example. So for this one here, f of x equal x to the second plus 6x plus 8, we do have a equals 1, which means the graph is going to open up. If a is positive, the graph opens up. If a is negative, the graph opens down. B is 6 and C is 8. C is always the Y-intercept. To find the axis of symmetry, the formula is x equals the opposite of b minus b over twice a. B is 6, so we go minus 6 over 2 times 1. That simplifies to minus 6 over 2, which is negative 3. So we do have an axis of symmetry at x equals negative 3. This is x equals negative 3. It's a vertical line. That's called the axis of symmetry, which kind of like cuts the graph into 2 halves, symmetrical, the right side and the left side of it. Now we need to find the vertex, and that is f of negative 3, where the graph is going to cross this line of symmetry. It's going to cross it at x equals negative 3, but we don't know which y. So we plug in negative 3, that's going to be negative 3 to the second plus 6 times negative 3 plus 8. Simplifying, we get 9 minus 18 plus 8. 9 minus 18 is negative 9. So we have negative 9 plus 8, which is negative 1. So the vertex is at negative 3, negative 1. Down below the y-axis, 1 unit. Right there. Now we need to find some points to the right of that and to the left, but they're going to be symmetrical, so we could reduce some work. This is the main point in the middle of the table. That's my vertex, negative 3, negative 1. Let's go to negative 2. So in the graph, we're going to the right, 1 unit, and then negative 1. On the other side, we're going to go to negative 4 and negative 5. If you take your time and plug in negative 1, that's going to be negative 1 to the second plus 6 times negative 1 plus 8, which is 1 minus 6 plus 8. And that is 3. 1 minus 6 is negative 5. Negative 5 plus 8 is 3. So negative 1 and 3. That is right there. Because of symmetry, we could find one on the left, same distance 2 units from the x-axis, and same height. And that is going to be at negative 5. And the height will be, or the y value will be, also 3. Now you could just go from there and graph it, because it doesn't have to be by hand perfect. But if you take your time, negative 2 will give you an output, and that is also going to be the same output at negative 4. So negative 2 will give you negative 2 squared plus 6 times negative 2 plus 8. That's positive 4 minus 12, 6 times negative 2 plus 8. And that is negative 8, that's 4 minus 12, add 8 to it, which is 0. So at negative 2, the output is 0, right on the x-axis. At negative 4, it's going to be the same thing, because of symmetry, it's going to be negative 4, 0. So we don't have to take our time and plug in the point negative 4. Graph it, and that's going to open up as we agreed from the first step, a equals 1 positive. And all what we need left is the domain and range. The domain is going to be all real numbers, because parabolas, they go right and left without any restrictions. In short, instead of writing all real numbers, we could just write R with a 2 lines up front just to distinguish from regular R. The range formally is a set of numbers, y being called y, and in our case the graph starts from below, down below at negative 1 all the way up. So greater than or equal to negative 1. Number 2. A is negative 1, the leading coefficient. So the graph is going to open down. Instead of writing open down, I'm just graphing a graph that opens down. B is negative 2. We need it for the axis of symmetry. C is 2 also, which is the y-intercept. So the graph is going to cross the y-axis at 2. Keep that in mind. Now let's find the axis of symmetry, which is x equals minus b over 2a. That's minus, or the opposite of b. B is negative 2 over twice a, and a is negative 1. You have to be careful with the negative signs. So the top part will be positive 2, down below it's negative 2. Divide 2 by negative 2, which is negative 1. So we do have an axis of symmetry at x equals negative 1, to the left 1 unit of the y-axis. That is my axis of symmetry. X equals negative 1. It's a vertical line. Now to find the vertex, we need to see where the graph is going to cross this line, what location on the y value. So we take the negative 1, plug it in, which is negative 1 to the second, minus 2 times negative 1 plus 2. The negative outside stays. The negative 1 to the second will be 1, so we still have a negative sign. Plus 2 because negative 2 times negative 1, and plus another 2. So it's like 4, take away 1, which is 3. So we know the vertex, which is a main point to start, at negative 1, comma 3. So let's mark it. Right there. That's negative 1, 3. So the graph is gonna turn around and go down at that location. That's called V, or the vertex. So let's mark it in the middle of the table to go right and left of it. So that's my vertex at negative 1, comma 3. And we have 0 on the number line to the right of it, but we know what 0. 0 is going to be the y-intercept. 0 is going to be 0, 2. And if you take your time, plug in some numbers to find more. Here's 1 to the right of that, 2 units of the x-axis. Plug in 1, just minus, and the 1 square, minus 2 times 1 plus 2. It simplifies to negative 1. So we have 1, comma, negative 1. Because of symmetry, we could transfer it to negative 3, which is 2 units to the left of the axis of symmetry. So also at negative 3, we get negative 1. You don't have to take the time and plug it in. As you can see from the graph, I marked 1, negative 1 and negative 3, negative 1. They're the same distance from the axis of symmetry and the same level. 0, you could plug it in, but it's known to be the Y-intercept, see? So that's going to end up 0 plus 0 or minus 0 plus 2, which is 2, which is already marked on the graph. At -2, it's going to be also leveled at 2 because of symmetry. And now we are ready to graph it. Opens down, goes through the vertex with symmetry. Finally, we come to the domain and range. Looks like I skipped that. For the domain and range in number 2, in case if you want it, it's all real numbers for the domain, and range is, because we went up to 3 and we went down from 3, it's going to be y less than or equal to 3. That's for number 2. Here we have a equals to, so it's going to open up. B is -4 and C is 3, which is the Y-intercept. So we mark it. To find the axis of symmetry, it's the opposite of B minus B over twice A. -4, that's 4, over 4, and that's 1. So x equals 1 will be the axis of symmetry. That's where the line is going to cross, or the graph, and it's going to be symmetric to its right and its left. Now, our main point is we need to know where's the turning point. We don't just call it that, we call it the vertex. Take the 1 and plug it in. That's 2 times 1 to the second minus 4 times 1 plus 3, which is 2 minus 4 plus 3, which is -2 plus 3, and that is 1. So the vertex is 1, 1. Here's the vertex, 1, 1, and let's mark it. Okay, now that goes in the middle of the table to keep us focused with symmetry. And we go to its right and its left. To its right will be 2, 3, and its left will be 0 and -1. Now, to the left 1 unit, that's going to be the Y-intercept, which we could see it from the graph 0, 3. To the right, same distance, 1 unit, will be the same level, so 2, 3. And with that, I mean, you don't need more points. You have the line of symmetry. You have the vertex, where the turning point is going to be. You know that opens up. And I have 2 good points to my right and left, so I graph it. Now, domain. The domain is going to be all real numbers. Keep that in mind. It's always all real numbers. And range will be the y values. And the y starts from 1 all the way up. So we say y greater than or equal to 1. So that's 3 problems out of 6. There is 3 more. Number 4. A equals -2, which means the graph is going to open down. But notice we're missing the x term and the constant term. So that should be a quick one. B is 0 and C is 0. So it's going to cross the x-axis at 0. The y-axis. I said the x-axis by mistake. So the y-intercept is at 0. Now let's find the vertex. Minus b over 2a, that's minus 0, but there is nothing called minus 0 or -0. It's just 0. 0 over twice a, and a is -2, is going to be 0. 0 over any number is 0. So we have x equals 0. Even if you take your time, plug it in, you're going to get also 0. So that's the axis of symmetry, which is the y-axis. Same as the y-axis. So the graph is centered, let's say. And if you take your time, plug in 0, you get 0. The vertex is the origin, and the graph opens down. But we need some points. So let's try some numbers. -1 going to the left of it 1 unit, and -2 2 units to the left, then 1 unit to the right, and 2 units to the right, 1 and 2. If you take your time, plug in -1, that's going to be -2 times -1 to the second, but -1 to the second is +1. So it ends up -2. So the order pair is -1, comma, -2. And here's where it should be. Right there. -1 on the x values and down to -2 on the y-axis. Because of symmetry, I could copy it to the right, so I should have the values 1, comma 2 also on the table without plugging in 1. The graph is going to open down, and if you take your time, plug in -2, that's going to be -2 times 2 to the second, which is -2 times 4, and that's all the way down to -8. That's -8. So the order pair will be 2, comma, -8. Let's see 2 and -8. Here's 2, -8, and because of symmetry, we should have one on the left, 2 units to the left of the the axis of symmetry, which is the y-axis, same level down at -8. And we're ready to graph. The graph we said earlier that opens down, so that should do it. The domain will be, as stated before, it's always all real numbers. And the range is the y values, and as you could see, the graph is below the x-axis, touching the x-axis, so I'm going to say y less than or equal to 0. Number 5. A is 1. B is -4. And C is 4. Because A is +1, the graph is going to open up, and C is 4, which is the y-intercept. So the graph is going to cross the y-axis at 4. Let's find the axis of symmetry. Minus B, that's minus -4, over twice A, that's 2 times 1. That's a +4 on top, over 2, which is 2. So x equals 2 is my vertical line. In this case, it's going to be the axis of symmetry, right at x equals 2. To find the vertex, where the graph is going to turn, and will have a max or min, we need to plug in 2. F of 2 will be 2 to the second minus 4 times 2 plus 4. 2 to the second is 4 minus 8 plus 4. And that is a -4 plus 4, which is 0. So the vertex is sitting on the x-axis because the value of the y is 0. 2, 0. And that's the vertex. Now, if you go to the left, 1 unit will be at 1. If you go 2 units to the left, will be at 0. To the right, same idea, 3 and 4. We know that the y-intercept is 2, so 0, 2 is already known and it's marked in the graph. Because of symmetry, I could just copy it to 4. Same distance on the other side of the x-axis, of the axis of symmetry. As you could see, it's because of symmetry, I could mark it as 4, 4. You could add more points. I believe that should do it to see the graph with the vertex, with the Y-intercept, with the axis of symmetry. Domain is all real numbers, and range is all the Y values greater than or equal to 0. The last problem, we have A equals 1. So the graph is going to open up. We have B equals -6. We need that for the axis of symmetry. We have C equals 8. So the graph is going to cross the y-axis at 8. So we call it the y-intercept. So let's mark it before we forget. Let's find the axis of symmetry. X equals minus B, but B is -6, over twice A, so 2 times 1. That's a +6 over 2, which is 3. So we have the axis of symmetry at x equals 3. That's my axis of symmetry. So I'm going to have a graph to the right and a graph to the left. That's going to open up, similar on right and left, and it's going to go through the y-axis at 8. Let's find where the point that's going to be turning around, which is called vertex. In this case, it's going to be minimum. Plug in 3 squared minus 6 times 3 plus 8, 9 minus 18 plus 8, -9 plus 8, which is -1. So we're going to be at 3, -1. Just 1 unit below the x-axis. Let's put it in the middle. And let's see how we could finish this quick. We go to the left of 3 on the number line. 1 unit, 2 units, that's 2 and 1. Then to the right, 4, 5. And we could even add the y-intercept and take advantage. So I'm going to add a line. In this case, as you can see, I'm trying to squeeze the 0 and go to the other side and add 6. 0 takes me to 8, which is the y-intercept. I don't have to plug it in or think too much about it. It's already done. 6 will be 8. Because of symmetry, 3 units to the right of the x-axis, the line of symmetry, will be at 6. Because of symmetry, it's going to be leveled all the way up at 8. And that should do it. To give you the numbers for 1 and 2 to make it smooth and clean graph. If you plug in 1, you get 3. You plug in 2, you get 0. Because of symmetry, 2, 0 will be the same like 4, 0, same level, same output. And because of symmetry, 1 took you up to 3, so 5 will take you up to 3. So, just to make it a clean graph, this is 5, 3, and this is 1, 3, 4, 0, and 2, 0. Finally, we finish it by mentioning the domain and range. Domain will be all real numbers, and range will be all the y values greater than or equal to -1. That should do it. 6 problems, graphing from standard form using basic ideas, y-intercept, axis of symmetry, and the vertex. Of course, paying attention to A, which is opening up and down. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.